Hello, everyone, and welcome to today's SANS webcast, Cloud Data Protection. My name is Carol Auth of SANS. Today's featured speaker is Mark Giesland, SANS Community Instructor. He will be moderating today's webcast. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Mark.
All righty. Thank you, Carol. And thank all of you for being here and your participation in this. I did want to just tell you a little bit about myself before I got started. I have been in the security and the application field for application development field for a number of decades. I started out a life as a software engineer, although even in my undergraduate degree, my focus was on security. Then about 10 to 15 years ago, I moved more directly into the security domain and ended up leading an AppSec team at Intuit Financial Services for a number of years, then moved to Citrix to do the same thing, and for the last 5 years I've been leading the global product security team for Azure. So I've been in the space for a while. I also teach for the SANS Institute, their web app pen testing class, Java security class, the GSEC course, and then also the new, fairly new, cloud security and DevOps automation class, which I'm also a contributor to. So, in which, in fact, most of this material is taken directly from. And so that's my background. I try to give back to the community through conferences as well. Founded Music City Con. And also I'm the leader and founder of the OWASP chapter in Nashville. And you have my contact information there. Feel free to contact me at any time with any further questions that we may not be able to address today in this webcast. So if we're going to be diving into the topic at hand in a moment, but if you are new to the cloud, your organization is either considering moving to the cloud or has only begun that journey, then as you'll hear me say through in a couple of spots throughout this webcast, you really need to get educated. I mean, it is extremely, extremely important to be well versed in the capabilities that are available in the particular cloud provider that you have chosen, or cloud providers, however that may be, if you're in a hybrid mode. But there's just so much to go wrong there, and it's not that the environment is inherently less secure, but it is just also new, and I see repeatedly pretty serious mistakes made by development teams as well as administrative folks in the way that they've deployed their systems into the cloud, and that's something it's not because they're being lazy so much or being foolish. It's just a lack of education on how things should be done and where the pitfalls lie. So I would strongly encourage you to look at the syllabus of the SEC 540 class as well as the SEC 545 class, Dave Shackelford's class, to if you are at all considering taking one of these SANS courses, that you'd look at those two courses and see the topics they cover, because they're pretty critical, and the two courses are pretty complementary. So with that, I'll jump into the topic at hand, which is cloud data protection. This is actually the fourth webcast in a series of webcasts surrounding the new content and the SEC 540 class, and I'll reference the rest of those webcasts at the end of this broadcast. So, but today we're going to talk about cloud data protection. Here's the agenda. You can see it there. We're going to focus mostly around the encryption options and key management. We will be heavily weighted toward AWS, as that is where my depth of experience lies. However, we'll also address Azure in the process. So the preliminary questions that I may be asking, and some of you have hopefully settled this, settled these issues already, but I know there are still quite a few organizations out there that are still trying to decide what they're going to do about the cloud, and are in some cases fairly fearful of going into the cloud. So these questions of whether you should move your data into the cloud and is the cloud secure are questions I certainly can't answer for you, nor can anyone answer outside of your organization. For one, they're not really questions with just a binary answer, yes or no. It's a lot more nuanced than that. And of course, it is really a risk management decision for your organization. But as you'll hear me discuss throughout this next hour, certainly cloud technology is not inherently less secure than on-prem technology. And when you consider all of the factors involved, including administration, the global view, basically, if I may say it that way, of your organization, your data, your resources that you get in the cloud, and as well as the multiple layers, millions upon millions of dollars is invested into the security by the major cloud providers such as Amazon, Microsoft, and Google. There's just a lot of issues that go into making those decisions, and but I would say that for the vast majority of organizations, apart from military or intelligence applications, where you have nation states that may be investing millions upon millions of dollars in capturing your data, or in the super high-end finance side, such as a company like Bridgeport or something, where we're managing massive hedge funds, where again you may have big money behind attacking you. Other than those environments, I would say the vast majority of us probably could feel pretty safe moving to the cloud, all other things being equal. So, and with the caveat, as I mentioned earlier, that it's a new environment. There's a lot of things you can screw up. You're not going to have the same expertise that you had for on-prem systems. You're going to need to retool and learn a whole heck of a lot of stuff. And you need to do that before you dive full force into the cloud. You're going to have to train your development teams. If you've got a huge organization with a lot of Agile or DevOps teams out there deploying directly to the cloud, and they're empowered to do pretty much what they want to do, you need to get ahead of that, and you need to educate them. You need to provide the framework so they can move quickly, but move quickly and securely. And you can do that. You can move quickly and securely, but it does take a lot of planning and forethought and training education. So with that, I'll dive into the technical side of the talk and start with the encryption. Like on-prem systems, you have a number of controls that need to surround your data protection policy. It's not just about encryption and key management, of course. There's a whole heck of a lot of other things that go into this, just like there are on-prem. So your access control mechanisms are critical, and possibly I might say more critical than your crypto, even though maybe less sexy. And then the way you segregate your data, including in the cloud on an account level, as well as on a resource level, such as an RDS instance. These tactics and mechanisms are extremely important. And so even though we're going to be centering on the encryption and key management aspects today, these others are just as important and probably more important. And again, I'd mention if you want to learn a lot more about IAM, particularly in AWS, but also in Azure, I would recommend again Shackelford's SEC 545 class to dive into that if that's all new to you, because it's a whole new world in the cloud and on-prem. Okay, so in encryption, I'll start with AWS, and I'll round up encryption with a little bit on Azure. But in AWS, there are two basic forms of encryption. One called server-side encryption, and the other is client-side. The names are rather clear what they imply. But in AWS, server-side encryption is by far the most used. So it's available on virtually every service that AWS provides, but I say virtually because there are services, you may be surprised, don't provide it. It wasn't until about a year ago that DynamoDB provided server-side encryption. So, and there were other services. Generally, AWS works in sort of their own DevOps way, where each service is run by different teams, and they deploy services as soon as they think they're viable. And they may deploy new services without full functionality in the security space, such as server-side encryption, for instance. But generally, if it's a service that's going to be widely used and encryption is important to that service, they will be coming out with it soon. And at this point, the vast majority of services for persistence that you would consider using certainly provide server-side encryption, including Dynamo as the most recent one to be added to that set. So again, as the name implies, the data is encrypted by the AWS service upon receipt. So it is not encrypted in transit unless you're using TLS, of course, which hopefully you are. You would, but of course it is encrypted before it is ever persisted in whatever storage mechanism is being used on the back end. There are multiple ways of managing the keys. We'll talk about that shortly, but they're very service dependent. Most of them will support KMS. Some of them will support other options as well, but it is service dependent, and that's something you need to be aware of as well if you're new to, particularly to AWS, is that the options vary from service to service, and we'll touch on it, just two of those to demonstrate that. But you can't assume just because it's the way you do it with RDS that you're going to do it the same way with S3 necessarily. So it does vary between services. The nice thing about server-side encryption is it's basically completely out of your hand. It's out of the developer's hands. You're not going to make any implementation flaws, at least in terms of the crypto, because you're not doing it. It's all handled for you. It's virtually painless. It's essentially, in most cases, just flipping a switch, if you will, and turning it on, and then identifying what master key you want to use. Here's just another slide on it, giving some more details in the graphic. The couple of details that may interest you on here is that for server-side encryption, AWS does use always AES 256 in GCM mode. So that is, you don't really have an option there. And there is, we'll talk about key management in a moment, but there are the options in case you are very concerned about that, of actually managing master keys, generating master keys outside of AWS, but we'll get into that when we discuss key management. Okay, so then we've got client-side encryption, the other end of the spectrum, and it's only when I say it's provided as an option for select services, I'm saying, of course, you could always do client-side encryption if you're going to roll your own, right? You could implement, even if it's you're encrypting data that's going to, say, go into a relational database, if you chose to use a format-preserving cipher, such as there are modes of AES that are format-preserving, such as those sold by voltage and pushed by voltage. You could actually do the encryption on outside of AWS on your client, and then actually upload the data into or insert the data into the database, and that's always an option, right, if you're going to roll your own. What I mean here when I am talking about provided as an option for select service by AWS, is there are certain services, such as Dynamo and such as S3, that will actually support and have mechanisms for supporting client-side encryption, and will actually provide you the means to do that. So, but it's not widely available as an AWS provided option. Okay, data is encrypted on the client, so naturally you're going to have encryption in transit as well as in rest if you're using client-side encryption. But once again, you're probably using TLS, so the in-transit portion may not be critical to you, but again, it depends on if you're using end-to-end encryption or not. So just something to keep in mind. Client typically uses the crypto libraries provided by AWS, but that's not a requirement. And sorry about that. Again, you have options for key management. For those that are the most, well, I can't really say that, I guess, as a simple black and white statement, which I was going to make, which for those that are on the more paranoid side, and I don't mean that in a negative sense, you're just actually far more cautious and careful about your data. Client-side encryption probably is more secure, all other things being equal, but because of just the separation essentially of the functionality and the difficulty of compromising multiple systems that you would have to do if you're going to crack that. However, again, all other things are never equal, and the fact that you're going to have to do a lot more work, and your dev team may have to do work to implement client-side encryption, means that maybe it's not as secure as server-side. So it depends on the circumstances, of course. So a lot of things to consider there. Another example, what we're trying to demonstrate in this graphic here is basically, of course, the key management portion could be either done on-prem, outside of AWS entirely, and simply you're uploading your data, if you will, into AWS, or it can be done inside of an AWS service. So when we say client-side encryption, it could be the client could actually reside in AWS, or the client could reside on your own external network. Okay, here is go through a couple of examples of ways to use this. I'll start with S3 because S3 is the most complex, and then we'll look at RDS, which is the opposite extreme. Probably one of the reasons S3 is so complex is that S3 has been around forever, and so it has evolved over time, and as it's evolved, they continue to support the older options. You can be the judge of which of these are perhaps the most secure. I'll give you some of my thoughts on that, but you definitely have a lot of options here. So there are 3 different server-side encryption options in S3, and the differentiator between those 3 is the way you're handling keys. So you can either, and they've got their own little acronyms because they're so frequently referred to. So you can either have the server-side encryption with KMS completely managing your keys. You can have server-side encryption with S3 service managing your keys. That's SSE S3. Or you can have server-side encryption with the client or the customer providing the keys. So those are all server-side encryption options, even though the client will be providing the keys in the third one. And then, of course, you have the client-side options. And I'm listing them as 3, although in case it could vary. In essence, you are doing using AWS's SDK on the client, and it depends on how you're managing the keys, whether you're providing them or you're using KMS, or you can just, again, like I referred to earlier, on any service, certainly you can roll your own if you want to go through all the work and providing that and make verification and making sure your implementation is secure and correct. So a lot of options. You can see here I'm trying to indicate what this is just server-side encryption options, the top 3 on that previous slide of the various features provided. You can see I got KMS all green, so I tend to favor that. I don't see a lot of reason to use SSE S3, that is server-side encryption with S3 service managing your keys. Because there's really only one reason or 2 reasons I can think of. One is legacy support, and you've been doing it this well along. The other would be that you don't want to pay for the the keys, basically, because every CMK and KMS will cost you $1 a month. Not a lot of money, but unless you have thousands of them. However, it's just the master key in KMS that would require that fee, whereas it basically comes along free for S3. But I would say don't be penny wise and dollar foolish. When KMS manages the keys for S3, it does provide you a lot of other options, as you can see here, such as the master key is actually protected in either an HSM or what Amazon calls an HSA, which is a hardened security appliance, and we'll get all into that in a moment of how secure that really is. They both provide automatic key rotation, but in the S3 state, when S3 is managing the master keys for you, you obviously, there's no way to distinguish access controls to the key versus the object itself. And that's a subtle nuance, but if you have access to the object, you have access to the key. There is no separate specification for who has access to the key, whereas in KMS, you have your own key policies of who accesses the key, which is completely independent of the data. And then, of course, in KMS, a huge benefit is you have a full audit trail through CloudTrail. And then, of course, if you're doing it your own on customer, it depends on how you implement it. Right, but in essence, you're going to have to implement it all yourself. Although you do get out of the box, in essence, an independent key and object access control. Okay, here's just some code examples, just using the CLI, just to demonstrate some of the subtleties here. And it's also very confusing. And these exact same, this code basically will have the analogous types of code, whether you're using the REST API or SDK. Okay, so the top one is using a KMS, a key in KMS as the master key. These are not, the master key is not what is actually encrypting the data, by the way. The master key, though, is encrypting the data encryption key, which is being used to encrypt the object. So, and the master key is what is stored in KMS. The second one there is using S3 to manage the master keys. It's kind of odd the way it's specified there, but again, that's for historical purposes. It just says server-side encryption AES 256. That might make you think that the top option there is not using AES 256, but it is. So that's just the way you specify S3. Management of the keys. And then finally on the bottom you've got customer provided keys, and as you can see there, you're actually having to, when you upload the object, provide the key, because the keys do not reside and are never stored in plain text in AWS. So you have to provide the key to upload the object, and you will have to provide the key to decrypt the object. So in the second, the last line there is just an MD5 hash of the key base 64 encoded, not base 64 encrypted, but base 64 encoded, just as an integrity check. So there's some examples. Last slide, pretty much on our AWS encryption, is the RDS, using it in RDS. RDS is kind of the opposite extreme in terms of the complexity. You've got all those options in S3, which can be confusing. But RDS, you really only have one option. Server-side encryption. There's no client-side encryption, again, unless you roll your own, which is totally transparent to AWS. The only one AWS provides and is aware of is server-side encryption, and the keys must be managed by KMS. So there is no option of either an RDS provided key management solution or a client provided key management solution. So fairly simple. There are some caveats to using RDS encryption, but in essence, everything associated with a database instant is encrypted, including the snapshots, as you can read there, read replicas, the backups, the logs, everything is encrypted. And it's completely transparent to the app. So it's analogous to TDE if you're familiar with TDE, but it's not really the same thing, but very similar, at least the way you use it. So this is just our slide on Azure. we've got a number of things going on this slide, but Azure provides analogous services to what AWS provides. Some of them are very, very similar, like the way encryption is done, the way envelope encryption is done, very similar to the way AWS does it. Although you're just obviously using different services, there are some nuances there you need to be familiar with. The access control is integrated with Active Directory and use RBAC to control access to keys and objects. And then there are some capabilities. Azure has come miles, right, in the last few years. 4 years ago, I would not have been recommending folks go to Azure personally. But the story has completely changed at this point, and they've really come up to speed. Microsoft has done a fabulous job, and in some ways have exceeded Amazon's capabilities. So definitely worthy of your consideration. Okay, on to key management. Excuse me, I seem to have a little tickle here going on in my throat, but we'll go on to key management at this point, which I find a fascinating field and a super complex field, and it's foundational. I mean, we were talking about strategies for data protection. One of the linchpins of that strategy, your strategy, is your key management. Sure, IAM is extremely important, like I said, but another absolutely fundamental, critical piece and foundational to everything you're doing is your key management. All your security, all your crypto stuff is for naught if you do not protect those keys, and more than just protecting the keys from exposure, if you do not protect the keys from ever being lost. There's one thing worse than your keys being actually stolen and being able to be used to decrypt data, and that would be for your keys to be utterly lost, right? So if you lose a master key and you're not properly protecting it and having redundancy and offsite protection and all sorts of things, and you lose it, I mean, that's probably going to go out of business, right? You've just lost access to all your data that was encrypted under that key, or the data encryption keys that were encrypted under that key, and vice versa. So it is absolutely critical to get key management right. And historically, it's been very difficult and very expensive. I remember the days a number of years back when we all wanted to have HSMs, right, as the creme de la creme of key management, and but they were so expensive, and very few organizations that I was working with at the time were willing to invest in properly in what they needed to do with key management. So they were doing their own thing, a lot of rolling their own key management and split keys and trying to do various and sundry things to do this properly, but it's a nightmare to get right. There's just so many pitfalls, so many things you can do wrong. And I wouldn't say, it's not like crypto in that we always say, right, don't roll your own crypto, but it's almost there, right? Rolling your own key management is, you don't want to do it unless you really have deep expertise and are very careful in how you're doing this. So because of that, because it's so critical and because it's so hard to get right, I'm very thankful to both Amazon and Microsoft for providing very mature, robust, sound solutions for key management, which we'll discuss right now. So just some basic overview of KMS, which is Amazon's AWS's key management service. It is on the back end. It is the keys, the generation of those keys, the protection of those keys are all secured. I have I'm saying HSA there because that's what Amazon calls their hardened security appliance. But they have behind those HSMs. So it's basically a network, if you will, very highly protected, highly segregated of HSMs and these hardened security appliances. The master keys never leave that domain. They never leave the HSAs and the HSMs in a plain text form. There is no mechanism for exporting them. There are no APIs for exporting them. There's no way for those keys to get out of there. That's why one of the reasons if you choose to import your own master keys and you lose your copy outside of AWS, then you're toast. There's no way to get that master key out of KMS. Now you could still use it, of course, assuming it's still present inside of KMS, but there's no way to actually export it out of there. So you would never have your own copy again if you lost your external copy. We'll get into that more in a second. So they're backed by HSAs and HSMs, so pretty secure. You have automatic key rotation, at least it's an option. You don't have to do it, but it's certainly a huge benefit, and there are some limitations on that, which I'll touch on as well. But if you're using standard KMS, standard CMKs, that are KMS generated, you have automatic key rotation as an option. And it's very easy to integrate with almost every AWS service is seamlessly integrated with KMS, so it's very easy to use. I talked about protecting your keys. KMS does a great job of doing that, ensuring that should any disaster occur or data centers be destroyed through natural disaster or whatever it is, you will not lose your keys. It's highly auditable, as I mentioned. Every single action that occurs against a key, whether it's creating a data encryption key, encrypting a data encryption key, decrypting a blob of data, whatever it may be, the actions are logged in CloudTrail. Of course, if you'd have to be turn on that and be using CloudTrail, but it's all logged. So you have a full audit trail available to you. And then in the case of some sort of serious compromise, you can safely and immediately disable access to master keys. So there are two options. I say delete or disable because it depends, again, on where the source of the master key material lies. If it's off-prem, you can delete it immediately. If it's in AWS generated through KMS, you can disable access to it immediately and then eventually delete it after a safety period, because they don't want you accidentally deleted it and then say, whoops, I didn't mean that key, I meant the other key, or false alarm, we didn't really have a breach, sorry, can I have my key back? If they deleted it immediately, answer would be no, and you'd be toast. So, there is basically a waiting period, although you can disable access to it immediately, so it will not be able to be used to decrypt data. And if you change your mind because you made a mistake, you can re-enable access to it through a particular API. I've been hinting at this, what does it look like sort of architecturally? KMS is just the service interface into this highly secure domain for the keys, the HSAs and HSMs. And like I mentioned, there's no way to get that information out of that domain. Services simply make KMS requests to say, generate and encrypt my data encryption key, give me a copy of it encrypted, give me a copy of the data encryption key in plain text. You can also ask KMS to decrypt it if you don't want to store the plain text outside of KMS, which you shouldn't. These are data encryption keys I'm referring to. The master keys never can come out of KMS in a plain text form. So very well done, very, very secure, very robust. As you can tell, I'm pretty excited about it. So, a couple other concepts that you need to be aware of when you're talking about KMS is what do these terms mean? You will see this term CMK thrown around a lot. That's customer master key. And some people will say customer managed key. It's not really a customer managed key. It's a customer master key, and it doesn't mean the customer generated that master key. It just means the customer requested a CMK to be created, gave it a name, etc. Can use it however they wish and associate it with certain services, rather than the automatic default master keys that AWS generates for every service that you have. So the automatic ones are, let's say you have RDS and you're using RDS, there is a default per region a master key created for RDS or for S3 or for whatever else it may be that you're utilizing. However, these CMKs are not those. The CMKs are ones that you explicitly say, I want to create it, I'm going to give it a name, and now I'm actually going to, I want you to use this key as my master key rather than the default key for RDS. The CMKs give you a little more flexibility, and those are the ones they charge you for, the ones automatically generated. The default keys they will not charge you for. However, you get greater capabilities with the CMKs than the defaults. So now there's a data key, right? So your data, in a typical fashion, you're not going to encrypt. It's kind of analogous to the way, you know, we use a hybrid with asymmetric and symmetric encryption, but that both the master and the data encryption key here are symmetric. But it's still analogous in that the master key is really only used, you can use it for more, but generally it's only used to encrypt data encryption keys, right? So, and again, those crypto operations occur within KMS. So you can have KMS encrypt a master data key for you, or you can have it decrypt a data key for you. But those operations take place inside of KMS. The data keys themselves and the use of those data keys takes place outside of KMS. KMS will generate the data key for you, but it will provide it to you in a plain text format as it was a certain API call, so the service can then use it to encrypt bulk data, and then the service will typically store, they call it envelope encryption, which I've got a diagram on in the next slide. Envelope encryption will store the encrypted data along with the metadata surrounding the data encryption key being encrypted with an identifier for this of the CMK that was used to encrypt the data encryption key. So it's not a new concept. It's a concept that's been around a long time, this hybrid model of encryption. And it provides basically a split key concept and provides greater security for the CMKs, as they're not being used to do much other than encrypt and decrypt data encryption keys. So you also, and I got a diagram there showing you the envelope encryption, which gives you a visual representation of what is going on I just described. But in addition, it's good to know about this encryption context that gets associated, KMS associates with the crypto operations. When you ask it to encrypt and decrypt data, you associate with it a context, and inside of that context, you can actually provide certain types of integrity checks that when it is decrypted, it can actually perform the integrity check and make sure that somehow or another you didn't mix up keys, basically. But the context can also be used almost like a tag to be logged. So you can put in the context what you like, and then those values will actually appear in the log, as well as being CloudTrail logs, as well as being used for integrity checks. Okay, for keys in KMS, there are key policies, which again is really critical to understand. I'm going to have to speed up here a little bit, because keys are not managed, access to keys are not managed through IAM policies like everything else in AWS is. You have separate key policies, because keys are, they're just of such so critical to security, they're managed independently. And it is theoretically possible, you wouldn't want to do this, but it's theoretically possible to create a key and then remove all of the key policies associated with that key, and then basically there would be no way to ever get access to it again, even on the root, from the root account. So, but that's probably not a problem you're going to run into occasionally. I do have a policy example right here that's actually showing granting full rights to the AWS root account. You do not have to do this, and so if you didn't do this, the AWS root account would not have full access to that key. So, but in this case, we're choosing to grant it to the root account. We're not using the root account for anything, but in the case of an emergency, we needed to get access to that key. We would have access to it through the root account and be able to do whatever we want. I'm not necessarily recommending you do that, but just demonstrating that is an option. And wanted to make clear the distinction between IAM policies and key policies. Okay, this was what I mentioned earlier, or hinted at, that you can actually, this didn't used to exist, but it's been around for at least a couple of years now, where there are those organizations that say, well, I don't really trust the cloud service provider to generate my master key material, or maybe you have clients that have certain restrictions on how the master key material has to be generated and stored, et cetera, and they just, since you can't see the implementation of KMS, perhaps you have your own reasons for why you want to generate that yourself and keep it in your own HSM off-prem, out of the cloud on your own infrastructure. If you choose to do that, you can with KMS. It's referred to an external CMK. So you end up creating a CMK, you label it as external, and what KMS will do is just basically create a CMK placeholder, if you will, a resource. It gets an ARN and all of that, but it has no master key material, so it's useless until you import the master key material, which you would generate on-prem. There are some limitations on this, so you really need to think carefully before you choose this option, because you are going to lose the ability to do auto key rotation, which you get with KMS generated master key material, and you also need to make sure you are protecting that master key material, because KMS will not provide all those durability guarantees that it does for CMK generated master key material. Okay, Azure Key Vault, jumping over to the Microsoft side, they took a different approach to KMS. I'm not talking about Cloud HSM, which is in here. It is discussed in the class, but we're not going to talk about Cloud HSM here just in the interest of time. But Cloud HSM is AWS's managed HSM service. Basically, you get your own dedicated HSM, but it's managed by AWS, and that's distinct from KMS, right? It's a different offering. So Azure Key Vault has sort of merged, if you will, the Cloud HSM idea that AWS has with the KMS idea, and with AWS's Secrets Manager concept. They've merged all those together into the Azure Key Vault. So you have a lot of different capabilities in Azure Key Vault. You can use it for general application secret management, right, which is what I'm highlighting here. You can also use it for encryption key management, like what we were talking about with KMS. It does that as well. You can use it to manage your TLS certificates, right, as well, and provision those and reissue those and all of that. So it can act like a managed HSM, very much like Cloud HSM, but it also acts as a secrets manager. So you have various capabilities, which is kind of nice that you've got all this rolled into this one service. So pick your poison. If you like that idea at Microsoft, you like the distinguishing of these various services into their own specialties, like Amazon has chosen. You have those choices to make. Here's just some example code of using Azure Key Vault as a secrets manager, essentially. It's basically creating a secret, encrypting a secret, etc., listing secrets, etc., decrypting secrets. So that's the brief Azure discussion. Okay, and as we were talking about secrets management, we'll close up here with these various and sundry concepts of secrets management in AWS. So in AWS, you're typically not going to use KMS to do general, right, application secrets management, like API secrets or whatever it may be that you need, that your apps need. You're not going to use KMS to control those. It's going to be supporting that on the back end, maybe with a master key or whatnot, but it's not going to be managing your secrets with it. You're not going to be interacting with KMS every time you need to decrypt an app secret, right? AWS provides two ways of doing this, application secrets management. right? And that is through the parameter store, which is a sub-function of SSM, and that has been around for a long time and is essentially free, although it has some limitations. And I want to say about a year ago, probably a year ago, maybe, yeah, I think about a year and a half ago, Amazon rolled out the Secrets Management service. So the Secrets Manager is a dedicated Secrets Manager service. So it's going to do it better in general than Parameter Store. However, it comes at a price. So, but it does. I got a slide up here that will show you kind of the differences between the two. So you can see this here that again, Secrets Manager gives you a lot more green check boxes, but they do charge you. But on the other hand, Parameter Store has a limit on how many secrets parameters you can create and protect through the Parameter Store. So you may, if you've got a huge volume of secrets, you may not be able to use Parameter Store. You may hit that limit. I know some folks that have, but you may have to use Secrets Manager. But just realize you've got two options here, and you really need to understand the differences between these two. As Secrets Manager is probably going to be enhanced at a faster rate than the Parameter Store used as a Secrets Manager, just because it's in Amazon's interest and it's specialized service just for this. So that makes sense. But you do have two options here in AWS. Okay. Finally, I'll wrap up with just mentioning besides all of what we're talking about here, KMS and Azure Key Vault, there are third-party solutions you can use, and I'm familiar with folks that have done it this way. HashiCorp Vault is a very good option if you, for whatever reason, decide to do all of your key management and all on-prem. That you can integrate these into AWS. They have support for this. Likewise, Voltage. Well, you may have your own reasons for using an appliance like Voltage, but one may be their support of format-preserving encryption, which is potentially an interesting option you may want to look into. So, basically, to conclude, I would say both of these major cloud service providers provide very sound foundations for robust data protection strategy in the cloud. They are not inherently less secure than what you're doing on-prem in 99.9% of the cases. But you do need to be aware of how to use them correctly, and you just have to be cautious because, like I mentioned here in the second bullet point, the features are just legion. There's just so many ways to get it wrong. And it's not that the services and the capabilities are insecure, it's about the way you use them, right? So education is just all the more important in this case. So, and be aware of just be aware of a lot of the limitations of various services and that the capabilities vary from service to service. KMS and Azure Key Vault are both are first-class key management solutions, and I would strongly recommend you consider those. And if you are deploying your systems into the cloud, I would strongly recommend using one of those two services, unless you have very, very good reasons not to. So, at the very end here, I just want to mention SEC 540. The cloud security and DevOps automation has been recently updated. In fact, it's basically continuously being updated because that's the nature of the cloud. On a weekly basis, things are changing, literally, right? And not with the course, but with the cloud. And so the course is being updated quite frequently to try to keep pace with that. They've just added, which is really cool. If you have taken the course before, you might be interested to know they've just added the Net Wars bonus challenges. So it's not like a pen test CTF, but we use Net Wars as the platform like you would in a pen test CTF, and It's essentially like boot camp hours. There are challenges, questions. There's a coin that is awarded, and to the victors. And so we added that. There's more Azure content being added all the time, and far more than I have presented here in this presentation. And so take a look at it, especially if you've not taken the class before. It is, I mean, I've taken a lot of SANS classes over the years. I've taught a number of SANS classes, and it is an extremely realistic class. We work in the cloud for most of the course, and the feedback I have over and over again is the course is very accurately represents kind of the challenges that folks are actually dealing with in their day-to-day jobs, dealing with DevOps and with the cloud and moving all their stuff into those domains. So finally, there's a Cloud Security Summit coming up, Cloud DevOps Summit here in November. You may want to check that out. And they have it every fall for I think the past 3 years, maybe now in Denver. And have some really awesome speakers. Typically leaders in the DevOps and in the cloud security space. So definitely check that out. Highly recommend that. And with that, I will conclude and pass it over to Carol. We're going to move into questions here.
All right, thanks, Mark, for that great presentation. We do have some questions ready for the Q&A. However, if anyone has a question for our presenter, please enter it into the questions window now. What are the reasons not to use default keys and go with I think it says CMKs instead? Yeah.
You have, like, for instance, if you're using RDS, the CMK, if you're using a CMK, you actually have greater flexibility in the use. So the default keys, RDS is probably not the best option to choose, but because when you create an RDS instance and you choose that you're gonna encrypt that instance, you have to provide a key, whether it's a default key or the CMK, and you can't actually change the CMK even if you're using a CMK. But the key rotation capabilities are you have greater flexibility with auto key rotation CMKs, and you can actually disable a CMK, right? So if you needed to disable the key for whatever reason under a disastrous sort of breach scenario, you can disable the key, the CMK. You can delete the CMK ultimately if you had to. You can't do that with the default keys. So there are just those are some examples of various options you have with a CMK that you don't have with the default keys.
All right, thanks. How will the key management work if you switch to another cloud provider? In other words, can you take your keys with you?
Good question. Well, certainly you cannot take your master keys with you. So if you move to another cloud provider, essentially you're going to have to export your data anyway, right? So you're going to have to export the data somehow and re-encrypt it through that process, and then again re-encrypt it, decrypt it, and re-encrypt it in your other cloud provider. So no, you cannot take the master keys with you. In fact, I mean, it's a security feature, but of course it's an inconvenience if you want to move cloud providers. Let me qualify that. If you are using a KMS generated master key, so where the key material is actually generated within KMS, within that security HSA-HSM security domain, there's no way to export it. It's not possible. Therefore, you cannot take that key with you. Now, if you had your master key imported, then when I went through that option, then you would have a copy of that master key or master keys. You know, you're probably not going to have one. So in that case, yes, it would be feasible to move to another cloud service provider and take your key with you because you have a copy of it. So it is in that case, yeah. So that may be a very good reason why you would import your master key material, but you have to weigh that against the downside of the lack of ability to rotate the keys, which is a huge limitation, right, of an imported master key. I mean, key rotation is a pain, right, in the neck, and to do it and get it right. And if you are allowing KMS to fully manage your master keys, then and Azure has similar capabilities, then you are actually you get it for free basically out of the box. It's very cool the way that it's done, and it's done very similarly in Azure. So it is you basically have versioning of your master keys, and then the versions of the master keys are used to encrypt the data encryption keys, and those versions are tracked in that metadata. So it's all transparent, but you can set a schedule for when they're rotated and all of that sort of stuff. So it's but yeah, if you really had to do that, I mean, of course you would always get your data out of Amazon, and they provide options for pulling all of your data out of Amazon, right? And so you can always opt for that. But if you were working on a smaller scale and you just wanted to export your data and basically be able to decrypt it and re-encrypt it in your other cloud provider, then you would have to have your master keys off on your own infrastructure.
All right, thank you. Any recommendations for multi-cloud customers?
Where I currently work, we do have we're a hybrid. We use both Azure and AWS. So it is for key management. We're not really sharing that across those cloud providers. So they're fairly distinct. I personally, Shackelford, I don't know, he probably had greater insight into this than I would, but I would not, recommend. You would have to have this. I would not recommend sharing, say, a product, deployed products, its infrastructure across different clouds, right? You'd want to deploy it into AWS or into into Azure or into Google or whatever it may be. However, you may have other apps that are running in a different cloud service provider, and that's the way we've got it. So we keep our key management distinct between the different cloud providers. So trying to manage it all across multiple cloud providers it's going to get pretty complex, and you're going to lose a lot of the capabilities that the native capabilities of those cloud providers give to you. So yeah, I would not recommend trying to have a master management of the keys outside of and across basically cloud service providers.
All right, well, that's all the time we have for today. Any questions not answered during this webcast can be submitted to q@sans.org, or Mark, I'm not sure if you provided contact information or not, but I can forward them to you if any questions come in.
Yes,
so thank you so much.
Thank you.
Okay, great. All right, well, thank you so much for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.